Hello everyone, welcome to week 6. So today we'll be looking into lecture 13. That's going to be our chapter 4 section 4.5, which is about moment of a force about an axis. So the objectives of this section will be you'll be able to determine the moment of a force about an axis using scalar and then vector analysis. So there are times we are interested in finding the moment of a force that it produces some component of rotation about a specified axis. So by learning up this one, we would be able to use to solve those type of problems. So a typical application of this method is assume that you have a force P is applied. So the person is going to be creating a moment ME using his flex handle socket wrench. So this moment MA will act up on all the arm towards in the socket to turn that one, right? So we need to know what will be the moment it will be created along this one to so we should be knowing so what will be our moment that will be created along this. So what happens to the moment that will be created along the arm that we are holding up? So that's going to be the arm we are holding up. So let's look at this one. Let's imagine you have a box with the three forces acting on it. So we have F1 and then we have F2 and then we have F3 acting on. So we need to find the moment of the force about the axis. So we used a similar procedure we used previously. So that is going to be our moment is going to be the force times the perpendicular distance that we are interested in. So that's our moment is equals to force times the perpendicular distance. That was the scalar. Or in vector we can say moment is equals to our position vector times the force. So we will use the same thing, but we will see how we are going to apply that to find the moment about the perpendicular axis. So just consider from the previous example, we have only the F1 force is going to be acting. So that's only going to be our F1. So when this force is applied, the box will turn about the x-axis. So that's going to be turning kind of like that in a counterclockwise direction. So our box is going to be moved. So it doesn't matter if the force is acting at this edge or it's moved along this right edge of the place where it is acting. Why is that? Because for the particular force that we have over here, if we consider the perpendicular distance, so that's our perpendicular distance. On the third figure, we can see our perpendicular distance. So no matter what, where the force is applied on this right edge, is it applied here or if it applied anywhere on those right edge, this perpendicular distance is going to be the same. So it doesn't going to be changing the moment created along this x-axis because the perpendicular distance is going to be same. So we have our moment is F1 times our d, but there's no change in the perpendicular distance. So we can move it along any direction. So what happens to the moment about the axis if the force is moved along this right edge? So we look into that right now. So if we move along this right edge, there is no change going to be the force because that's going to be F1 times our perpendicular distance to the x-axis. So this distance is not going to be changing when you are moving it parallel to that x-axis. Let's see what happened to the moment about the axis if the force is moved downward. So just think about it. So if we had the force and if I change it here or if I move it downwards here, what happens to the moment? We know that the moment is going to be F1 times d1. So d1 is the perpendicular distance. So you can see that if I am going to move this downward, my perpendicular distance is going to be shrinking. That means, for example, if I'm on the top, let's say it's d1. If I'm going to be at the bottom, it's d2. So you can see d2 is going to be less than d1 because d2 is going to be 0. So the moment if I replace F1 times d2, that's going to be 0. So if I'm moving it along the perpendicular distance, then I know that moment is going to decrease or increase due to the position. But if I'm moving about the point where the force is acting, which is parallel to the x-axis, I know that moment is not going to change. So let's see about the F2 force. So when this force is applied, we know that the box is going to be moving kind of like that. So the moment created by the F2, sorry, that's going to be F2. So that's going to be F2 times the perpendicular distance. So that's my perpendicular distance. So my force is acting like a vertical force. So the distance, imagine that's going to be that my distance D1. So same thing, let's ask the question. What happened to the moment if the force is moved along the left edge? So if I'm moving along this left edge, what's going to be happening for my moment? So I know my moment is going to be F2 times the perpendicular distance D2. So what happens to D2 if I'm moving along here? That's going to be D2, that's going to be D2. So everything is going to be D2, right? So there is no change in the moment. So let's see what happens to the moment if about the f-axis, if I move the force to the right edge like that. So my force acting over here, I'm moving towards the right edge. What going to happen? It's going to decrease because my D2 is going to be decreasing. So my moment is going to be decreasing. So this will be the change. So that was scalar analysis. We know the distances, we get the force and multiply. But in most cases, if you consider 3D cases, getting the distance perpendicular is going to be sometimes difficult. So let's see a pipe system over here, and we have a force F acting downwards. So I wanted to find the moment about any specified axis. It doesn't need to be X, Y, or Z. It can be any axis. Let's see, I want to find the moment about AB. So I want to find how this force is going to be rotating about this axis AB. So how do I do that? Previously, we looked how to find the moment about any point, right? So if I want to find any point, I know like I get the position vector from this axis from A to here or anywhere along this axis. I need to get the position vector and then I multiply it by the force. I was able to find it about like in a 3D space. But if I want to find with respect to my AB, what should I do? So let's look at the equation where we use the matrix here, IJK. So this one was like general term, right? Generally about any point. So if I'm going to be looking at specified axis, I'm going to replace that with the unit vector in that specific axis. So that's going to be my moment about AB axis. So I just put the scalar product. So I put the dot product in front of my previously existing moment equation. So I'm replacing my IJK, is that the unit vector in XY direction, with the unit vectors acting in that specified axis. It can be any axis. You get the moment, you get the unit vector in that axis and put it in your matrix. So that position vector can be from anywhere from your AB to anywhere in the line of action of your force. It doesn't need to be a specific point. It can be from anywhere from your AB axis to anywhere from your the line of action of your force is expressed. Make sure that your force is expressed in Cartesian vector. Then only you can get the IJK terms and put it over here. Okay, so only the difference is going to be the unit vector we are adding. So let's look at an example. So the moment of you're asked to find out the magnitude of the moment that is produced by these 450 newtons about this x-axis. So that's my x-axis, so that's my force. So how do we do that? So we had to use the vector analysis because the coordinate direction angle of my forces are given. So first I'm going to be getting the force in the vector component. After I'm getting that, I wanted to see what's my unit vector, and then I'm going to get what's my position vector, and it's just going to be the scalar product of my cross product of my, that's R times F, moment and force. First, let's get the magnitude of the force. So what's my x-axis making the angle with the force? 60. Then y 60, 45. So that's 450, 120, 450, 60, and 450, 45. Why it's 120? Because I know that it's in negative x direction, so I have to get it in the positive direction. So that's 180 minus 60. So that's why I have here 120. So when I solve it, I get my force, which is equals to negative 225 in the x direction, and then 225 in the j direction, and 318 in k in the z direction. So getting the position vector, I said we can get it from anywhere along this y x-axis to the point where my force, the line of action where my force is acting. But which is easier for us here? is to get where the B is acting. Why? Because the coordinate of B is given. So it's our task will be very easy to get the position vector from A to B because A is our origin, rather than getting from somewhere here to there or there. So make sure that which coordinate is given so you can use it in a smart way to get the answers easily. So for my position vector, I know that's what is the coordinate. So it's 150 in the x direction. How is that 150? So let's look at that. So that's my x. So that's my B point. So it's going 150 in B. So that's 0 minus 150 plus, that's in I. Then in the y direction, it's going to be parallel. That's 300. So 0 minus 300j plus in the z, if we see it's going in 100 up. So the force is directed upward. So it's going to be 0 minus what? So that will give my position vector, which is going to be negative 0.15 plus 0.3j and 0.1k. And I think I made a mistake. So it's going to be R. So let's look at that again. It's going to be RB minus RA. So what's my RB? It's negative 150 because it's on the other side. And I'm going to neglect A because it's 0. And this one is positive 300 and this one is upward. Sorry about the previous one. So that's going to be my answer. So it's B minus A, and always make sure that's B minus B because I'm going from A to B, so the coordinate should be B minus A. So the previous method where I did, it was B to A, so you can see the answers were reversed. So the unit vector, so that's the important thing. What's my unit vector in x direction? I know that the unit vector in x is I and y is j and k, z is k. So it's only in x direction, so I have only the unit vector in x. I don't have it in the y and z because all the others are perpendicular to that. So that's simple. So make sure that if you want to find out the moment in x direction, you know the unit vector is only I. If mine is in y direction, the unit vector is only 1j. And if it is only in the z direction, it's only the k. So you should be careful with that. So now I'm going to use my equation to find out what is my moment. So my moment is going to be I know this unit vector scalar product of my position vector times f. So I write my matrix. So it's 1, 0, 0 and everything. So finally my moment is going to be that. So that's simple as like that. So our only task is to find out the position vector. If the force vector is not given, else you have to find the force vector and then you have to get the unit vector. Okay, let's look into the next example. So they asked to find the resultant moment created by these three forces. So we're going to get the resultant moment about y-axis. We know that to get the resultant moment, we need to get the addition of the moment by all the forces. That's going to be the same thing. The only thing is we're going to find about an axis. Here it's y-axis. Okay, so let's consider F1. Will F1 create a moment about y-axis? Correct if you think no. If you think no, then you are correct. So there is no moment about my y-axis for F1 because it's going to be parallel to my y-axis. So if we know that the forces acting parallel, there is no any moment. So let's consider my F2. So what's going to be the perpendicular distance from y-axis to F2? So that's my y-axis, that's my F2. So my perpendicular distance, I know it's acting over in the edge of that box. So that's 1 meter. Let's see the direction. So my box is moving like that. So if I use my right hand rule, so I have my thumb pointed over there and I can see all my other fingers pointing in clockwise direction. That's why it's negative. So it's 160 times negative 1, so that's negative 160 Newton meter. Let's see F3. What's the perpendicular distance from y-axis to F3? That's going to be F3. So that's 10 Newton. So my perpendicular distance is the vertical one, so that's 1.5 meters. So what's my direction? So my force F3 is going to move my box like that. So if I keep the hand and see, that's going to be clockwise. So negative 10 times 1 point, that's 15 Newton meter. So the resultant is going to be negative 160 plus negative 15. So that addition is negative 175. So that's negative in the y direction. So opposite to y. So if I'm using right hand rule, my thumb points out there, and all the other fingers points out in the clockwise direction. So that's why it's negative, because it's in the clockwise and in the negative y direction. Okay, let's see the last example. Take your time to solve this problem in your own, and then pause the video and come back and see whether in which stage you are, whether you are approaching it correct. So we have the force applied, which is 200 Newton. The coordinate direction angle is given, so we know how to get the force in the vector Cartesian form. Then you need to find out the moment. So to find the moment, we need the position vector, we need the unit vector, and then the force. So take your time to solve this and come back and look into that. So let's look into my unit vector. Since the question is about x-axis, I know it's only I, other terms are 0. Then I need to get my position vector. So how do I get my position vector? So the distance is given. I directly draw the position vector from RO to A. So my A is lies in the y-axis, so there is no x-coordinate, so that's 0, and it goes in 0.3 from y, so that's 0.3, and it's in the height of 0.25. So I have my position vector. How do I get my force vector? I know the magnitude 200 times I know cos alpha, cos beta, and cos gamma. So it's 120 in x, 60 in y, and 45 in k with the z direction. Then I get my force. Then I use my matrix, so 1 0 0, because that's the unit vector. And then I fill up the position vector, then I fill up the force, and then I'm going to get the determinant. So that's only going to be this 1 times 0 point this one, because all the others is 0, so it's just that you get it. So that's going to be my moment. So that's positive, that's in counterclockwise direction. Okay, so that's all in this lecture sets, and that's going to be the last problem. So just give it a try and see how you can do it. The solution is already uploaded on the blackboard, so once you are done, you can go and check the solution. Make sure to try this problem and then check the solution. Don't just go straight into the solution and check it. Thank you, and see you all in the next lectures.